case of multi-dimensional arrays, we used to have n dimension represented like this, m1 up to mn, where the name of the array is b, and every collection of m1 and m2 mn data elements in which each element is specified by n integers. So we have m1 up to mn up to that much dimensions inside the array, and every element is specified by a list of integer. That means a particular element is already itself as a list of integers, or you can say list of numbers, such that k1 and k2 up to kn is the subscript value with the property as given earlier, having lower bound up from 1 to m1, as m1 is a list of elements in that dimension, again 1 to m2, again 1 to mn. In case of C programming, it will go for 0 to m2 minus 1, mn minus 1, and m1 minus 1, so on. An element b with the subscript values k1 and k2 can be denoted like this, as the subscript value are starting from k1 up to kn. It will be represented like this. Every element will be represented like this, k1, k2, kn. Similar is the case with this, name of the array is b. If we talk about the multi-dimensional array further, let us take an example, and C is an n-dimensional array, where length of the n-dimensional array, for a particular dimension we have to calculate the length. For length of dimension I, in case of C as the name of the array, this will be upper bound minus lower bound plus 1 in that particular dimension. So upper bound of I minus lower bound of I plus 1. This is how we can calculate the length of a particular dimension. Means in a particular dimension the elements can be stored, and similarly other dimension elements can be stored, and so on. This is how the multi-dimensional array will work around. So multi-dimensional array you can say as combination of multiple dimension based array. So if we talk about a 3D array, so 3D array is a combination of multiple two-dimensional arrays, and every two-dimensional array is combination of multiple 1D arrays. In that case we can say a particular dimension will have given number of elements. And in this case, for a given subscript ki, the effective index, we have to calculate the effective index based on that given dimension. Effective index means based on that given dimension, that index position ei in that particular, or as per that particular length in a given dimension I. It is represented by this. Effective index is ki, whatever is the value of ki given subscript, minus the lower bound in that particular dimension. It will give me the effective index. Like I want to access a particular element in a given dimension, so it will give me the effective index based on this. Subscript position minus the lower bound value in that dimension will give me the effective index of a given element in that dimension. Now the similar is the case with this address calculation of multi-dimensional array. Suppose C is the array, k1 to kn is the subscript positions, and by column major order this is the formula which you have to remember, and by row major order this is the formula, as multi-dimensional arrays are also represented in rows and column combinations. So it will be row major and column major formula to calculate the address of a given element in a multi-dimensional array. So this is again width, or you can say the size of any particular element in bytes. This is the base address or starting address, and this is the base address or starting address in case of row major, again width, and these are the effective index and the length of that particular dimension. This is the formula which is being calculated after separate deliberations. So this we have to use in order to calculate the address of a given element. So let us take an example. Suppose this is a 3-dimension array. This is the first dimension with lower bound and upper bound given. This is second dimension, lower bound, upper bound given. This is the third dimension where lower bound and upper bound are given. So we have to calculate the address of this element in which the value of k in one dimension is this, another dimension is this, value of k in third dimension is this one. Based on this we need to calculate the address of this element in 3D. So base address is required, so it is given as 200, width is required, it is given as 4, and we are also provided with the memory representation, that is row major order. So first we have to calculate L1. L1 is my length of the first dimension, which is upper bound minus lower bound plus 1, which is upper bound this one. This is representing first dimension, this is representing 2 dimension, and this is representing the third dimension, we can say. So 8 minus 2 plus 1, 7. Similar is the case with L2. That is 1 minus 4 plus 1. 1 minus 4 will give me 5 plus 1 will give me 6. Similar is the case with L3. So this is, in case of we have 4th dimension, so we have to calculate L4 also. In case we are dealing with 4-dimensional array, we have to calculate L4 also. This is how you can identify how much we have to calculate as per the generic formula of a multi-dimensional array address calculation. So this is how 10 minus 6 plus 1 will be 4 plus 1, that is 5. This is how L3 has been calculated. Effective index is length in a given dimension minus the index position. So 5 minus 2. So this is the 5 minus 2. So this is the lower bound. 5 minus lower bound, that is give me 2. Then for this minus 1, it will be minus 1 minus 4 minus 1 minus 4 will give me positive 3, as minus becomes positive for this 4, and minus 1 will be subtracted from it, so it will give me positive 3. And then 8 minus this 6, so it will give me 2. So this is how even into E3 calculated, and now we have to put these values inside that particular calculation. So for the row major order, this is the formula. So first we have to calculate E1 L2. This multiplication we have to perform, it will come out to 18 as per the values calculated before this. Then E1 L2 plus E3 we have to calculate this one. This will give me 21. Then it has to be multiplied with L3, this one, so it will give me 105. Then it will be added to E3, it will give me 107, and it will be not multiplied with L4 because there is no 4th dimension. So as per this formula, we have to go up to this particular only. So if we perform this, 200 is the base address, 4 is the width, and the internal one we have calculated as 107. Because we have to calculate up to only this particular part, that is the 3rd dimension, it will come out to 600. So this is how basically we calculate the address of a particular element inside the 3-dimension array, or you can say the multi-dimensional array. For 4-dimension, 5th dimension, this internal value can be further extended as per this scenario. So this is all about your multi-dimensional arrays.